What's up? This is Pang from LabVIEW by Example, and thank you for joining me today. I'm going to cover the various built-in data types offered by LabVIEW in this video. So I'm going to try to help you to reduce any confusion that you may have as to which data type to use in your programs, especially for unsigned numerics. So let's first talk about Booleans. A Boolean is a data type with two possible values, true or false. The Boolean data type is named after English mathematician George Boole, who introduced Boolean algebra in his books. So if I open up LabVIEW and drop down Boolean type with a push button under the Boolean palette, and I look at the diagram, Control E, I see a terminal with the TF on there, which means that it is a Boolean control. TF is true, false. So let's drop down another Boolean and make it Boolean 2. Let's call it Boolean 1. And Boolean 2. Okay, so we've now got what we need to do a lot of the Boolean operations from the Boolean palette. So there are several functions that you have here. You can AND, OR, exclusive OR, NAND. So if I put down an AND, for example, and I wire these up, and let's put a Boolean indicator as output. Let's call this Boolean result. So if both are off, get off, return one on, still off, but turn both on, becomes on. Okay? So if you look at the help of an AND, and then you look at the detail help, you can find a truth table for every one of these functions. So the truth table tells you what results based on the well, it's a breakdown of the logic function, and it lists the possible values for the function. Okay. So I won't go through all these functions in this video, but it's a good idea to really know your Boolean logic. Again, all these items in here. So you need to know Boolean logic really well to be able to code, not just in LabVIEW, but any other programming language. You're going to be doing a lot of checking of true and false states, if statements, case statements, etc., etc. And the other big benefit is that you'll understand how bits work when trying to understand the underlying way computers do math and store data, which is in binary. So let's go and cover binary by first talking about numerics. Okay, so let's remove all this. All right, so let's drop down a numeric control. Okay, as default, you'll see the signature terminal look of orange and the letters DBL for double data type. So let's change this representation. I'll cover double floating point data types in another video. So to change the representation, right click, representation, and let's pick the simplest one. Let's do an unsigned 8. So U8 represents an unsigned 8-bit integer or whole number, which is denoted in LabVIEW with the blue color for terminals and wires. Okay, so what does 8-bit mean? So that means that there are 8 binary digits used to represent a number. Before diving into all that, let's take a look at normal decimal numbers we use every day. When we write a number with several digits, the position of each digit tells us how much to scale and add to come up with the final value. So for example, for the number 125, you take the 5 and you add it to 20, which is 2. This is equal to the same thing as 2 times 10. And then you take that and add this to 100, which is 1 times 100. Okay? So it turns out what we're doing is that we're multiplying each digit by 10 raised to the power of the digit location and adding them up. So this is the same thing as, well, this is the same thing as 5 times 10 to the, 5 times 1, which is 5 times 10 to the 0. This is 2 times 10 to the 1 and 2 times 10 to the 2. So this is the 0th location, this is the first location, this is the second location, and these are the powers that you see here, right? Okay. So we can do this in code and verify it works. So what I can do is drop down a string. Okay, string. So first off, I need to reverse this string so that index value matches the digit position while going through a loop. So let's string, and where's my reverse? Let's just use this reverse string. Okay, I need to find the size of the string for loop. Okay. Okay. So what I want to use is the string subset function to look at each of these characters one by one. Okay, so I want to take one character, okay, and I want to take that position. So remember we reversed the string. Okay, so now I want to convert that string to a number. String number conversion. So I want that string to a number. Okay, so like I showed before, that string to number is going to, well, that number needs to be multiplied by 10 raised to the current location. So the current digit location is this I. So I can use power of 10. Okay. And if you multiply each one here, Okay, and we want to go ahead and cast that down to a unsigned 8. Okay, and so we need to keep track, add to our total each time. So we're going to add, and we want to add to a wire or a variable that is a U8. Okay, so we need a shift register to keep track of that value from iteration to iteration. Okay, and this can be our number. So I can just right click, create indicator, and number. Okay, so if I put in my string 125 and I run, something's wrong here. Oh, there should be 125. Okay, so pretty common sense here, right? But that's why. Well, that's the reason why is because we everything is in decimal. Okay, but when we look at computers, the decimal system that we're used to is just one way we can represent a value. In computers, at the lowest, deepest levels, no digit values other than 0 and 1 are used. And that's it. Computers can do all those amazing lightning quick operations by just using 0 and 1. But how are these zeros and ones translated into the numbers that we humans are used to in everyday life? So in binary, each digit is multiplied by 2 raised to the power of the digit position. So instead of 10 raised to the power of the digit location as in decimal, which is referred to as base 10, computers use a base 2 system. Okay, so for the number 8-bit number, let's do 1 0 0 1 0 0 1 1. So what we're going to do is take each of these and multiply by the position. So this is going to be 1 times 2 to the 0. So we're going to add each one. 1 times 2 to the first. Okay. 0 plus 0. These are the numbers from here. So this is the first. 2 to the second. 2 to the third. 2 to the fourth. 1 times plus 0 plus 0 plus 2 to the 7 times 1. And if you add all these up, it should equal to 147. Okay. So let's show this in LabVIEW. So all we have to do to our existing VI is take in the string, and instead of using power of 10, we're going to use a power of 2. So if I just right click, and now there should be a power of 2 function. I should hit replace exponential power of 2. Okay. So let's use 1 1 0 0 1 0 0 1 1. Okay, and we should have, if I run, 147. Okay. Couple of tips: you can always change the display of a numeric control or indicator to show the number in decimal or binary. So you can right click, you can say display format, and in the properties viewer, click the display format tab and select binary, and you'll see this is in binary. Okay, So another way to do this, if you have a later version of LabVIEW, is to right-click, visible items, radix. Okay, so now you have this section that you can click on and select how many or how to display the number. So just flipping between decimal and binary get you that. So you see the binary here is exactly the same as what the string was. Okay. So why would you choose an unsigned 8-bit number? So the answer depends on whether you're most concerned about memory use and are okay with the limitations that this data type has. So being unsigned, you can't make it negative, and there's an upper limit value that an U8 can take. So if I change all my binary digits to 1, so I say 1, 1, 1, 1, 1, 1, 1, 1. Is that right? Yeah. So the maximum is 255. So these limitations can cause you to write some really nasty bugs due to overrun logic errors. So let me show you an example. Say we have two values, x and y. So let's drop down. Well, I can just copy this, call this x, and call this y. Okay, they're both U8. So if I want to add up these two, okay, and let's create an indicator, U8 indicator, okay. So I'm just putting in 100 for x and then 200 for y. Should give me 300, okay. But when I run, I get 44. So what's going on here? Well, that's the result of simple binary addition of the two numbers. So just like addition, we just add up the digits as we go. And what's happening is that as you add the numbers, the numbers, the binary digits fall off. Okay, so you get unexpected numbers, unless you kind of really know what you're doing when you're doing a binary addition. So to prevent overflow errors like this, you can use data types that have more bits. You can go with 16, 32, or even 64. So let's set x to U32, U32, and then you can do a you can now you can look at the display format, okay, and if you look at the data entry tab, you can see what the default limits are. If I unclick this, you can see this better. You can actually change this to prevent somebody from going between two limits, but this is a maximum default value of a unsigned 32. Okay. So question is, why just not go with the big boy U64? So if I go U64, display format, entry, you got this huge number here now. Okay. So you could do that. You can just use this U64, but keep in mind that you're allocating 64 bits, and any value that's not over the 32-bit limit is just wasted memory space, and it's just all zeros in sitting there in your RAM. So it may be okay for one or two variables. So, but say you have an array of U64 of 100,000 elements. Not only will you be potentially reserving a bunch of memory with just zero, but you'll take a pretty big hit on array manipulation performance when working with the U64 versus U32 or U16 or even U8, right? So that's, you kind of have to watch out, not just using the biggest data type out there just for no reason. You kind of have to understand what's going behind the scenes on your computer. All right, that's it for now. Let's tackle signed integers next time. And all right, congratulations. You're now more knowledgeable on Booleans and unsigned integers in LabVIEW. Awesome job. Please, if you like this video, add likes or comments below, and don't forget to subscribe. If you need more LabVIEW how-to articles, go to labviewbyexample.com, and remember, you too can be LabVIEW awesome. Thanks for watching. Until next time.